So this is an excellent geo, geographic GIS related library called Raster Vision. So this is doing some amazing things which probably were not possible till I think about this library has come around. So I'm not sure if anything else is doing what Raster Vision is doing right now. But the very first look, and if you have been somebody who's been trying to do this earlier yourself, or you've tried something of this sort, so you will obviously realize this is quite difficult. So what he's showing here in one image, semantic segmentation, classification of the chips, and then object detection. So there are three tasks which are quite astounding and quite amazing tasks. And then I found many, actually not one, but I found many YouTube videos that I've gone ahead and linked here. So where have I linked them? Yeah. So I've taken the liberty to fork this, and I'm going to make some changes here. So uh, did I just? I wanted to. One second. Yeah, I think I did a lot of branches actually. Okay. So yeah. So there are some changes that I've done. I need to push that. I've not done that yet. But I've put the tutorials up here. And there are more tutorials which are there, which I'll just go ahead and Adi Rasan is, I think he's the lead developer. Uh, I heard this particular YouTube tutorial quite detailed, very well explained as to what is happening. Uh, but I started doing something, and I saw there one tutorial on their documentation, and where they have this one, the quick start. Here they are recommending that you go ahead and use a or get started with Docker and do all of this in Docker. Uh, I don't want to do all of this in Docker. I don't really prefer Docker. I would rather do it outside of Docker, so that I go ahead and uh, I'm basically able to put some print commands here, there, and do whatever I feel like. I don't get that freedom when I'm doing it in Docker. So what I've done is I have gone ahead and created this particular structure. Uh, so yeah, so I've created these two directories. One is code and one is output. Within code, like they say, okay, go ahead and put tiny spacenet in code. I've done that. So tiny spacenet is here. This is their code. What I've done is I've changed this opt data output because this gave me a lot of errors. I kept on getting a lot of errors because of this. So I've gone ahead and changed that. Uh, yeah. So I haven't taken all the logs, but some logs I've taken here. And so I don't know why it has skipped the analyze command and where the analyze command came from. I can't see it in the make file. The first I get is, I think, train only. So there is no analyze over here. I don't know where he's picking up the analyze, but he says he skipped that. So okay, fine. God knows what is happening. But he does get into train. Okay, then he says running train command, and then he's supposed to make this directory within output train. He doesn't. So this thing fails here only, and then keeps on failing because that directory is not created. So because I am running it out of Docker, which probably is not recommended by them. So there are issues. These issues will get solved, and I will definitely push the code here, and then we can see how it, how you could end up And this JSON, so this JSON got created, pipeline config JSON got created. I was pretty printed this, and I thought it would be good just to go through the type hints and just have a look what is happening. Uh, so all of this is supposed to happen. You suppose with an output, you're supposed to get a directory called predict, within which you will get something called scene 205. So all this is defined in the JSON, but the make steps are failing right now. So I'll fix the make steps and then let's see what can be done. And just to show you how I am getting all of this, wherever I am getting this info is my prints that I've gone ahead and I've put them in here in these files. So this is basically your where the library got installed, where Raster got installed. Within my Anaconda environments, so whatever environment name I've given, environment raster, viz, then within that lib, Python 3.10, site packages. So there I've gone and put some of these prints and all to see, to try and understand as to, how this thing is running and what is happening. Uh, so yeah, that's what it is as of now. So here I've put some of these prints to see how the flow is and what is happening. So ultimately, that it just requires that path. If that path is given properly, um, so it went and created this pipeline config.json, right? So that much happened, and then rest of it also, the make has run, right? The make has run. Uh, so the running train command and all this is coming from make only. Then it keeps giving this root temporary directory cannot be used. Uh, Now, why it cannot be used? This has got to do with the Docker. Now, if I'm not giving that path of Docker itself, then why is it giving me this error? I don't know. I'll have to check. So maybe I'll have to go further into his code and see what is this RV config and everything. I have not seen that yet. Uh, but yeah, I don't want to run it in Docker. I want to run it outside Docker so that I get to understand how this thing is working. That is my uh, that is what I want to understand. Yeah, so that's about it right now. But excellent library, well written code, well written documentation also. I'm not saying the documentation is bad. It's just that I don't want to follow the documentation, at least for this. And then there are other examples. Other examples are there. Yeah, all these tutorials. So over here, they're not talking about Docker. So they give something on top. They say, okay, if you not using Docker, you go ahead and use this configuration. So let me see. Maybe I will go this route. Maybe not go the Docker route. Let's see. But a very impressive library. And what they're saying, if this is happening, then with that also with PyTorch. And I heard his this video. He's very clearly Adil Hassan. He's very clearly mentioned that initially I think uh, they started off with the TensorFlow and then they moved to PyTorch or something like that. Something somewhere I think he mentioned. But good, as long as it's got a PyTorch backend, so that is great because everybody is moving away from TensorFlow. That is definitely a statement I can make in today's date after experiencing a whole lot of uh, legacy TensorFlow code. People are moving away from TensorFlow and Keras because reason could be that either they are too simple to implement and maybe they don't offer enough functionality, or it's just a trend that people are moving away from TensorFlow and moving to PyTorch. Really can't say. Yeah, so that's about it for now.